Welcome! In this video, we will build an intuitive understanding of relative velocity in one-dimensional and two-dimensional motion. Let's start with one-dimensional motion. Imagine two cars moving along a straight road. We want the velocity of car A as seen by car B. Relative velocity in one dimension is the velocity of A minus the velocity of B. Let's plug in numbers to make it concrete. Suppose car A moves at 20 meters per second to the right, and car B moves at 12 meters per second to the right. Then the relative velocity of A with respect to B is 8 meters per second to the right. Now, let's move to two-dimensional relative velocity. A classic example is a boat crossing a river. The boat's velocity relative to the water points straight north, and the river current points east. The actual velocity relative to the ground is the vector sum. In two dimensions, relative velocity is just vector addition. The velocity of the boat relative to the ground equals the velocity of the boat relative to the water plus the velocity of the water relative to the ground. If the boat goes north at 3 meters per second and the river flows east at 4 meters per second, then the ground velocity has magnitude 5 meters per second. Let's summarize. In one dimension, relative velocity is just subtraction. In two dimensions, it's vector addition. Once you visualize the motion, the formulas become very intuitive.